Hi everyone, my name is Will Ross, product developer here at SkyCiv, and I'm here to do a quick demo about the latest updates on SkyCiv's foundation design module. This update mainly highlights the integration of the finite element analysis for shallow foundations. And for this tutorial, I'll also be discussing the new interface update from last year's release. So let's begin. After selecting the foundation design from the dashboard, you can select the design code and units to create a file. For this demo example, we're going to use ACI, and let's try metric system. You can also open an existing file using this button, but here let's create a new file. So let's get started. Upon entering, the left part of the screen will contain the input tab first and default, and on the right part is the 3D graphics containing some summary data, settings, and the global axis system. For the left side, actually there are four main tabs here: the details, foundations, input, and results. In the details tab, you can add the project information. So in here, I'll add the name as Will Ross, ID number 1, company SkyCiv, designer WP, and the client say X, and also add a notes saying trial. Next is the foundations tab, where you can add multiple data. In one file, you can add isolated footing, combined footing, or even piles. But for this example, let's stick with a single model with ID number 1. Then there is the input and the results tab, which we will expand further. So let's proceed with the input tab. In this tutorial, we will design an isolated footing. So by default, it's the one appearing for the foundation type with ID number 1. Under the input menu, there are 6 other tabs we need to define in order to proceed with the foundation design. So let's start with the geometry. For the geometry, you need to input the footing and column dimensions. So for the footing, I'm going to make it to 1,800 by 1,800 millimeters and a thickness of say 550. For the column, let's stay with the rectangular shape, and I'm going to input 400 by 400 millimeters. For the height, let's set it as 1 meter or 1,000 millimeters. You may also add X and Z offsets here, and the render will automatically update on the right side. But for this example, I'm going to stay with a concentric footing example. So let's input 0 and 0 offsets. Next is the soil properties. The first is the surcharge area load, which will remain at 0. For the gross allowable soil bearing capacity, let's input 100. And you will see here that the subgrade modulus or the modulus of subgrade reaction automatically changes. However, this is only a placeholder from a multiplier of 100. That's for metric system only. And you may change the value of this input according to your actual geotechnical data. Then let's set the thickness to 1 meter or 1,000 millimeters, same as the column height. Angle of friction of 30 and coefficient of friction of 0.45. These two inputs is necessary for the sliding checks. You can also consider groundwater table here by checking this box. And as in here in the render, the The location of the groundwater table is set from the top surface of the soil. But for this demo, I'm gonna omit it for this example. Next is the material properties, which is also vital in the design. In here, we need to define the concrete, steel, and soil properties. For concrete, we'll just use the default values, normal weight for concrete type, strength of 3000 psi or 20.68 MPa for the metric system, and unit weight of 23.6, elasticity modulus, and Poisson's ratio. As for the steel strength, let's set it as 414 MPa, which is equivalent to a grade 60 rebar. Then a soil unit weight of 18 kilonewton per cubic meter. For the loads, let's add dead, live, and seismic loads. Let's add 150 kilonewton actual dead load, 10 kilonewton for live, and 5 for seismic. Let's also add some shear loads in both directions. Let's say 10 and 1, 1.5 and 0.1, 2.5 and 2.5. So this example basically describes a pin end column. So for a fixed end, you may add values for the moment. You might also wonder why loads on the right side of the render is somewhat different. This is because the render automatically applies the load combinations, and by default, it gets the maximum service or SLS combination. In the data box, you can see here the list of the service and ultimate combinations. You can also toggle this visibility settings and choose which load combinations to show. Now, let's proceed with the reinforcement tab. Here you can add top and bottom reinforcements. So just need to click this button if you want to show the top reinforcement. But for this demo, we'll stick with the bottom reinforcement only since this is typical for isolated foundation. So let's leave the bar sizes and the spacing as it is. Just gonna explain that the longitudinal bars are the reinforcements along the x-axis, while the transverse bars are along the z-axis. We also need inputs for the column reinforcements, but it is important to note that it's only needed for development land checks, and the foundation module does not design the column. For concrete column design, you may go to the SGG software as well as the RC design module. So here I'm just going to input some values. Lastly, to complete the design requirements, we need to fill the miscellaneous tab. This includes the factor of safeties for overturning and sliding, which we will set as default, as well as the development length factors, concrete cover 75 millimeters for top and bottom faces. Also needed is the punching shear edge factor, which is important to classify the columns for punching shear checks, whether it be interior, edge, or corner. And lastly, finally, we need to update or add an input for the mesh size. The current value is 0.2, so I think we should stick with it. You also have an option to preview the mesh here, and as well as the mesh ID label. So before I run the design check, since we're already complete with the inputs, allow me to have a quick rundown of the right portion of the screen, which contains the 3D graphics or render. As I've mentioned earlier, it has the data summary box, which contains the basic information of the model on the left part. and some settings on the right portion where you can show or hide some objects. You can also show or hide the load combinations here and adjust the concrete opacity for the render. There's also the orthographic view and the perspective. And you have the option to screenshot the image for your presentation and report. And now we're done with the inputs and images or image from the render. Let's hit the run button. The loading screen also is an addition for the module, so you can see the progress of the solver. So after its completion, you can see the results tab directly. So in the results tab, you can see the utility ratio for the multiple modes, and you can automatically see if your foundation passes or fails. And in this example, it seems to pass. You can also download the detailed report here for the complete calculations. You may download it as a PDF file or HTML file. Let's wait for it to load and have a quick rundown of the report. So this is the complete calculations or the design report for the isolated footing example. You can also have an in-depth analysis of the FEA results in the right side or the render side. In here, for the soil pressure, you can choose what limit state or load combinations to show. So let's stick with SLS and envelope absolute max, but you can also choose SL2 or SL1. And for the wood armor movements, you may also see the results for the top and bottom faces of the foundation plate. So here, let's choose ULS and envelope absolute max. So you can see the top and bottom results as well as the X and Z direction results. And that's it. I think that wraps up the new updates. And I hope this video enlightened you on the new capabilities of SkyCiv Foundation Design, specifically for isolated footing example. In case you have questions or clarifications, you can click the intercom button. Here you can leave a message and we'll be happy to assist you. On the next foundation tutorial, we'll be discussing combined footing examples, still using the enhanced module with FEA. Hope to see you there and have a great day.